Hey everyone, welcome back to Introduction to Bifrost Visual Programming. In the previous tutorial, we created a landscape by getting the point positions, using fractal noise and F-curve to change the positions, and reconstructing the mesh with the new positions. Today we're going to introduce fields and their applications in modifying geometries. In this tutorial, we'll use a combination of fields to drive the displacement of the points. And then with the same fields but different parameters, we displace the points again to create some texture. This way we can generate a landscape of more details and complexity. We'll also learn how to assign material in Bifrost for quick renderings. Now let's get started. A field is a function that associates a value to every point in space. The function itself is independent of the coordinates, and therefore can be applied to any set of points. For example, a temperature map is a scalar field, which associates a numerical value to each point, and a wind map is a vector field, which assigns both a speed and a direction to each point. Today we'll focus on scalar fields. Remember we used fractal noise and evaluate F-curve in the previous exercise? This time we'll use a combination of fractal noise field and F-curve field. First, let's create a plane. And middle drag it into Bifrost graph editor. And let's get fractal noise field. To visualize what values and pattern this field generates, we can use the node scalar field scope. Connect noise field to scalar field and the mesh plane to probe geometry. As we learned in the last tutorial, we can use a terminal for displaying the result. Let's increase the size and resolution of the plane. And hide it. Now we see the noise pattern displayed in colors. An alternative way to visualize the pattern is to use the node Assign Diagnostic Material. Connect the mesh plane to geometry, noise field to emission color, and the output to diagnostic. Disconnect scalar field scope. Now we see a grayscale image reflecting the numerical value it generates at each position. And let's switch to the top view to better visualize the pattern. Here, a value that's greater than or equals to 1 returns the color white, and a negative value of 0 returns black. Anything between 0 and 1 is a shade of gray. If we go to the parameters panel of fractal noise field and adjust the number of frequencies, we see that higher number of frequencies gives more details. And if we change the frequency, the scale of the noise changes accordingly, with higher frequency resulting in smaller scale noise. To use these numerical values to drive the displacement of the points, we can use the node Displace Points. Connect the mesh to points, and noise field to weights. This moves each point along its normal direction by the corresponding distance generated through the field. You may notice the vertical halo here at the port. This means that it's an auto port, which supports multiple data types, and a variety of things can be plugged in here. If we connect the out points to output, we see the modified geometry. Let's switch back to the perspective view. Here are the superimposed images of the geometry and the noise pattern. We can see that a brighter color, which represents a higher value, results in a higher point position. And the black regions, which represent negative values, correspond to the valleys. This displaced points node also allows us to change the scale and direction of the displacement. To scale the displacement vectors, we can change the number here, and this float value will be used as a multiplier to the displacement vectors. For example, if we increase the value, we see higher peaks and lower valleys. Let's turn off the diagnostic view. To change the direction of the displacement, click the plus sign here, which reveals the port for orienting. Let's get a value node to set the direction. We can change the type of the value by pressing this button and set the value type. In this case, select vector 3. Type in values 1, 1, 0, and connect the value to displacement vector. This changes the displacement direction from the default normal directions to 45 degrees in XY plane. For this exercise, we're good with normal directions, so let's delete this value node. A nice feature about fields is that they can be layered in different ways to create various effects. For instance, we can add the F-curve field on top of the fractal noise field to further modify the geometry. Connect the noise field to field and out field to weights. This gives us a combined effects from both the noise field and the F-curve field. Similar to fractal noise and evaluate F-curve, we can change the frequency to modify the number of the mountains. And we can go to the graph here to adjust the curve to further modify the shape. In addition to being added, fields can also be multiplied. Here are some examples of geometries generated from multiplying fields. Besides geometry manipulation, fields can also be used to influence simulations, which we'll cover in later tutorials. Now we're ready for the next step. To add more texture to the surface, we can apply the same fields again to the new geometry. Simply copy and paste the two fields together with displaced points. And connect the output from the first displaced points node to points. This moves the points along the normal directions of the new geometry. We can adjust the scale, F-curve, and frequency to fine-tune the texture. This allows us to create different features, such as bulbs, quartz, and creases. This method can be applied to all kinds of starting geometries to create different forms. For example, we can create a torus, increase its resolution, bring it into Bifrost, Replace the plane with this torus. Hide the original torus. And adjust the parameters to make it look like a donut. Let's switch back to the plane. So far, we have a lot going on in this graph. To make a graph look cleaner and easier to read, we can combine nodes into a compound. For example, we can select all the nodes we used for creating this landscape, right-click, select Create Compound, and rename it as Create Mountains. You can double-click the compound to access the nodes inside. To go back to the main graph, simply click the name of the graph here. We'll talk more about compounds in the next tutorial. Right now, our landscape has the default material Lambert with a gray tone. In Bifrost, we can assign material to a geometry and render it using R-Node. To create a material, go to Hypershade. We can select a material here, say Standard Surface. We can play with the settings here. For example, we can change the base color. To bring this material into Bifrost, hold the middle button of your mouse and drag it into Bifrost Graph Editor. And to assign material to a geometry, we use the node Assign Material. Connect out points to geometry, the material to surface material, and out geometry to output. In the viewport, we see that this blue color is applied to our landscape. Now let's do some simple rendering of the scene. First, under R-Node, Lights, select Sky Dome Light. Open Render Settings, where we choose the resolution of the image. Say 1K square. Then go to R-Node, open R-Node Render View, and click Start. And we have our rendered image. We can modify the material in Hypershade, say Add a Sheen. And select the color for it. The material in Bifrost will update automatically. If we render it again, we get a surface with a purple sheen. That's all for today. In the next tutorial, we'll learn how to create instances as a preparation for the simulations we're going to run. Thanks for watching, stay tuned, and I'll see you next time.